So this relative frequency table, there's just all decimals. You can tell if it wants a decimal or percent, depending on how your answers look. And this one is asking you to find what we call conditional relative frequency. I think every single answer option is asking for that. So for example, the probability that a student is between 11 to 13 years of age, given that the student likes baseball, and then it's giving you an answer that you have to see if it's true or not. So anytime it says given that, or out of, or something like that, it wants you not to divide by your grand total. And then whenever it says given that, whatever follows is going to be your denominator. And I'm not talking about the 0.34, I'm talking about the people that like baseball. So when we go back up here, the total people that like baseball is what? Or here's baseball. So 0.25, and then out of those, we're trying to see how many of them were ages 11 to 13. So that's 0.12, and then you'll have to put that in your calculator. So 0.12 divided by 0.25, is that the same thing that they said it would be? So that's why you're not going to pick A as the one that's true, because it really should be 0.48. And that's what you're essentially doing for all of these. So the probability that a student likes football, given that the student is between 8 to 10 years of age. So what's going to be my denominator for that one? So let's see. It should actually be 0.35. Because given that, whatever follows that is what your denominator will be. So like 8 to 10 years of age, that total is 0.35. And then before that is out of those kids, how many of them like football? Well, that's 0.12. So then again, I have to put that in my calculator. 0.12 divided by, oops, that's not 0.12 divided by 0.35. That's about 0.34. Is that the same what they said? So then you're not going to pick B. Because that is what it should be. For C, it says the probability that a student is 14 to 16 years old, given that the student likes basketball. So what should be my denominator for that one? Okay, should actually be 0.35. Because given that, whatever follows it, so out of the kids that like basketball, there's 0.35 of them. Well, really, there's more, but this is the relative. We want to know out of this many, how many of them are 14 to 16. So then what would be your numerator? .08. So out of the people that like basketball, this many of them are between 14 and 16. So then you divide those. I already know that's not going to be correct for that one, because if I'm dividing 0.08 by 0.35, it's not going to be 0.08. So I know C is not going to be it. So process of elimination, it would have to be the last one, and your answers might be shuffled. But let's compare. So we have the probability that a student likes baseball, given that the student is between 11 to 13 years of age. So what's going to be my denominator for that one? If you said 0.35, then you're correct. And because it's out of the, so given that, whatever follows it is your denominator. So out of the people that are 11 to 13 years old, there's that total. The amount that like baseball is 0.12. Put that in the calculator, 0.12 divided by 5. I get 0.34, and that's what that one says. So check all of them. Only one of them will be true for that one. And that's how you figure it out. So given that, whatever follows it is your denominator. Questions on that one? Questions on any others? Maybe number 7. Okay, so that one is a good one to go over. So to calculate the correlation coefficient, I've only really shown you how to estimate it visually from a graph. And this is from a data table. So what you would have to do, the only really logical way I can think of you being able to answer this one is to use Desmos to make this a scatter plot. So I'll show you that. I know I showed you how to use Desmos for that reason, but yeah, that's the only logical way to do it. I don't know if there's really a way to do it by hand to calculate it, but in the real world, even if you are in that field where you use a correlation coefficient, they would have you, it would be computer generated anyway. So might as well show you using Desmos. Now, what you would type in, you have to look at the two things being compared. So we have the correlation coefficient for the linear relationship between the number of absences and their grade. All right, because it is a bit confusing that there's 3 columns. Really, you're just looking at these two. These two are the things that are being compared. Now, which one depends on the other? Is it that your absences depends on your grade in the class, or that your grade depends on your absences? So in that case, then if this is what's dependent, that should go on which axes? The y-axis. All right, a way to kind of remember that is you can make a D out of the y-axis, you can't out of the x-axis. All right, but yeah, so then that means the times absent, which is independent, is down here. So then when you're plotting this, that's what, this is like your x and this is your y. You would have to put this entire table into your Desmos. I'm only going to show you a few so that we still have time to go over some other ones. But here's how you do that. So we pull up Desmos, hit this plus sign. You're inserting a table. And then you're just putting in your data points. Yes, you have to put all of them. So like 4, and then 87, but it really doesn't take that long. What's the next data point? 0.75, is that what you said? Okay, next one. Next one. Okay, I heard 50. What's the first one? Okay, and then next one. Okay, I'm not gonna, that's all I'm gonna put in, but really when you're doing this, you do need all of them. But just to show you, so when I zoom out, you can see it makes a scatter plot like that. You could kind of estimate it even from that, like it kind of looks like it's going downward. But here's how you can know for sure. You would type this in, and I would probably write this down in my notes if I plan to do this. You should. You just type in y1 squiggly x1 plus b, because that'll put in a trend line, and straight lines have y equals mx plus b formula, right? So that code to make Desmos do it looks like y equals mx plus b, and it's using these x's and y's that you put in your table. And yes, you would need all of them from your table. But then when you do that, look at just the R value, not the R squared. The R value is your correlation coefficient. So again, you would need to put all your points in the table, but just from those 5, it's estimating it to be about like negative 0.78. All right, other cool things that this does, you may not need it, but there's slope, there's your Y-intercept. It can even plot your residuals if you press this button, and then you can look at those. Would you say how do you know when your residuals are good or not? If they're closer to the x-axis, the better it is, your residuals. So yeah, that helps you with a different question, not necessarily number 7. But just letting you know, you probably don't need to plot your residuals today on this quiz, but just other cool things that this method does. And all you need is a table of values and to type this in. So questions on that? All right. And I will go back on the quiz. I probably won't do it for your practice just because there's too many. But for your quiz, if you're close to the correlation coefficient, that's fine. Like if that's supposed to be my correlation coefficient, but you put like -0.6 or -0.85, something close, I will give it to you. All right. Questions on any others from the practice quiz? Number 4. All right, so this one, using this graph, estimate what the y should be when x equals 10. So a few things you could do for this one. I'm not a huge fan that this is on the computer, because what I would do is I would draw a line as straight as possible through the middle of my data. Okay, so you will have a paper part of this test that you could do that, but you need to draw a line through the middle of your data. It's not important that it touches all the points, but that it's through the center of your data and that it's as straight as possible. And then from that line, you're going to pick 2 parts that you can see clearly. So like, for example, this kind of looks pretty clear to me on this line that I drew. So I would probably use that coordinate, which is 838. But you need 2 points in order to plug it into your slope formula, like that. So there's that. Let's see. Another one that I could kind of clearly see is this one that happens to fall on the line and is a data point. But the key thing is it has to be on the line. And then once you do, you make one of them x1, y1, the other one x2, y2, and plug it into your formula. So the way that I labeled it, it's going to be 11 minus 38 over 2 minus 8. And there's tons of other points you could have picked, but these were the ones that I thought were clear to see. So on top, I get -27. On the bottom, 2 minus 8 is -6. We're going to divide those. And then so my slope is about 4.5. It's okay that they're slightly different from each other, but they just need to be close. Yeah. Okay. Would be close to 4.5. It might be 5, it might even be 6, I don't know. It might be 3.5, it'll be close to that. And then your y-intercept, if you can clearly see it, great. It kind of looks like it's 0, but I can't really tell. So I'm gonna have to plug it into y equals mx plus b. All right, we just figured out the slope is 4.5. And for the xy, just use one of your coordinates that you had picked earlier. So in that case, my y is 11, my x is 2, and then plus b, and you're solving for b. So 4.5 times 2 is what? And then get the b alone. How do I move the 9 to the other side? Whatever you do on one side. Okay, good. 11 minus 9 is 9, 10, 11. I counted. So then in slope intercept form, it's y equals 4.5x plus 2. And then you have to plug in, because it wants you to estimate what the y should be when x is 10. So kind of a long part of this. I'll see if there's any ways to make it simpler. But once you do that, 4.5 times 10, I think is 45. Someone correct me on that. And then plus 2 makes it 47. So let's see what my answer options are. All right, so I'm thinking A. Is it A? Did someone get it right? Okay, so that's what I did. What you could also do, since you can clearly see the points, you could also do like what we did in Desmos, where you just have to make a table and let it estimate the, what does it want? Well, let it give you the equation, let it estimate the slope and y-intercept for you, and then you're just plugging in whatever x value they want you to plug in. So you can do that too. All right, questions on this? Questions on others from the practice quiz, Mariana? Number 6. Okay. So number 6, and then this might have to be our last one because we want at least like 30 minutes for this. So Mary was driving home from California. The graph records her distance from home and time spent driving. So it's not labeled. Let's label it. The two things being compared is distance from home and time spent driving. Which one should go on the x-axis? The time spent driving. Which means then my distance from home would be on my y-axis. Because that depends on how long I've been driving, right? Not the other way around. So then when we are answering this, because it's asking about slope and y-intercept, so we might want to know what those are for this. How do you find slope? Good. You could do rise over run if the numbers are nice enough. I recommend this one a bit more just because it'll help you with more problems on your test. So then for that, you'll want to find 2 points on the line that you can clearly see. So what are some points on the line that we can see without estimating? 4 and 100. What else? 2. Okay. And there's plenty of others you could use. As long as you can clearly see them and they're on the line. So then make one of them x1, y1, the other x2, y2, and then solve for your slope. So in that case, it's 100 minus 200 over 4 minus 2. What's 100 minus 200? And 4 minus 2. And negative 100 divided by 2. Negative 50 is my slope. And all day we've been using different coordinates and we each time got negative 50. All right, the B is your y-intercept. So if you can clearly see it on your graph, great. Can we see it? What is it? All right, so then plus 300. So this is my equation. Now let's answer the problem. The answers are shuffled, just so you know. So really like pay attention to what it's saying versus just what letter it says. I'm going to try not to have to erase, but we'll see. So would you say that the y-intercept is how fast she needs to go in order to get home in 6 hours? No. All right, 300 doesn't really make sense. What is the 300? The 300 is her distance from home when she started, right? Because the y-axis is distance from home as time passes. So when she started at her y-intercept, it was 300. So it's definitely not going to be the speed she needs to go. B, at least on my screen, yes, the y-intercept is 300. C is the slope negative 65. So then don't take that one. Is the y-intercept 6? Don't take that one. The slope represents how many miles she still has to travel. All right, no. The slope is how much it's changing by, and it doesn't really specify that it's hours on this one. but let's assume it's hours. That's how much her distance is decreasing by each hour. So minus 50. Thank you. I can do this. Okay. Oh, that's how much her distance is decreasing by, and I know it's decreasing because it's negative, each hour. All right, so for each X. So not E on my. Is the Y-intercept how far she is from home when she starts driving? Yes. Is the slope of the line negative 50? And then would you say that the slope is her average speed? So I actually disagree with that. On your test, it'll be more clear. Like the way that this is phrased, to me, this is how much her distance is changing each hour. Not necessarily her speed. Because her speed shouldn't be negative. So that's why I said it's not that. On your test, it will be more clearly stated. It'll say something to the effect of the slope gives a rate at which the distance is changing. So when it's phrased like that on your test, then yeah, I would agree with that. But the way it's phrased on this practice, I would say, no, that's not her speed. That's how much her distance is changing. So I did have to fix the key so that it stopped saying that that one should have been one of the right answers. So it will rescore. So if you only had those three on there and it previously marked it wrong, then it'll be marked right. It'll just take like a couple hours. But does that make sense? Any questions? All right, we do have to take our quiz now if we're gonna have enough time. But if anyone has like a last minute question, you know, just let me know. Yes? All right, so your code, it's gonna be in the secure